Koenigsegg created dark matter engine that will change the industry forever. Dark matter has always been a topic of interest due to its mystery, extreme, and unfathomable power. On the flip side, the Swedish brand Koenigsegg is famous for designing their ridiculously powerful hypercars. So no wonder if we say Koenigsegg has created a dark matter engine, it will spark a lot of interest both among science and car enthusiasts, and sound bizarre at the same time. But it's no clickbait. The news is true. Koenigsegg has really made it, and is going to install it in their future cars. So if you're curious to know more about this unbelievable engine, keep watching this video to the end. In 2020, Koenigsegg pulled the wraps off the Gemera, which marked their debut into the world of four-seater supercars, and made quite a splash with its unique six-phase electric motor, pumping out a solid 800 horsepower. This motor set new standards for power density, and it was all the buzz in the automotive world. Originally, the Gemera was planned as a plug-in hybrid Grand Tourer, but things took an interesting turn. Fast forward to a special event in Ängelholm, Sweden, where Koenigsegg revealed that the Gemera was getting a new powertrain option. They decided to offer the Gemera with a 5.0 TTV8 engine from their Jesco model, all because the Geneva Motor Show got cancelled. The story behind this tech innovation is pretty cool. It all began during the development of the Jesco, when the engineers were toying with the idea of swapping out the engine and transmission. They came up with a 9-speed gearbox they call the light-speed transmission, or LST, which does away with the usual stuff like a flywheel, clutch, or hydraulic coupling. Instead, the output shaft of the TTV8 engine now serves as the input shaft for this LST. The result? They've got what they call the light-speed tourbillon transmission, or LSTT. Now where things get even more interesting is with the dark matter e-motor. Koenigsegg didn't take the easy road. They set out to create something groundbreaking. They looked at the cutting-edge technologies and found inspiration in switch watch internals, where a tourbillon improves accuracy. So they decided to revolutionize the Gemera's powertrain. Most electric cars go for the traditional radial flux motors, where the magnetic flux is perpendicular to the rotation axis. It's simple and effective, plus it's kinder on the production budget. But Koenigsegg had bigger plans. They wanted the best of both worlds, and designed the dark matter motor, which combines aspects of both radial and axial flux technology. Axial flux motors, which generate magnetic flux parallel to the rotation axis, are theoretically more efficient but come with their own set of challenges, like maintaining consistent air gaps and effective cooling due to strong magnetic forces. The yokeless variant of axial flux motors, pioneered by companies like Yasa, is known for its high torque density and compact structure. Koenigsegg's dark matter motor takes the rotor and makes it bigger compared to the stator, accommodating more magnetic flux. This unique design boosts torque and power production. Founder Christian von Koenigsegg, quoted in a piece by Auto Evolution, said that the technology is achieved by taking an axial flux motor and increasing rotor diameter against the bulk of the stator and optimizing the stator OD, or outer diameter, to be able to accept this extra flux. They even use a distinct coil shape, possibly in a more U-shaped configuration, and an all-carbon fiber design to keep the weight down. The motor also boasts a 6-phase stator with 2 separate 3-phase AC inlets, allowing for higher amperage and torque production. These folks have truly gone above and beyond to create something extraordinary. Radial flux motors have a unique design with a stator that looks like a donut, surrounding a rotor equipped with outward-facing permanent magnet. The stator applies a radial force, which makes the rotor rotate. This type of motor is completely used in electric vehicles, including Lucid's efficient motors. On the other hand, axial flux motors also use permanent magnets, but have a different setup. In this case, the stator coils are arranged in a way that their faces are parallel to the largest faces of the permanent magnet. This results in a slimmer and flatter electric motor. The magnetic force flows in an axial direction, which is why they are called axial flux motors, instead of a donut shape. The components of an axial flux motor are more like stacked pancakes. Koenigsegg seems to have come up with a motor design that combines elements of both radial and axial flux technology. While the exact designs are not fully disclosed, one possible approach could involve using U-shaped stator coils. These coils would be shaped like bending a paperclip around the spine of a book, with the rotor placed inside the U-shaped coils. This setup might include 3 sets of magnets on the rotor. However, according to a report by Auto Evolution, Koenigsegg's explanation suggests a different approach. They mention increasing the rotor's diameter and optimizing the stator's outer diameter to accommodate the extra magnetic force. In essence, Koenigsegg has developed a unique and innovative motor design that combines the advantages of both radial and axial flux technology. The specific details of their motor, referred to as axial flux, remain confidential, but it's clear that they've pursued a new approach to achieve higher performance and efficiency in their electric motors. This particular motor, known as the dark matter e-motor, is lightweight, weighing less than 40 kilograms, and is enclosed in forged carbon fiber. According to Koenigsegg, it generates an impressive 800 horsepower and 922 pound-feet of torque, which translates to around 600 kilowatts. Given that the Gamera operates at 800 volts, we can calculate that the motor would require about 750 amps of current to produce 600 kilowatts. This is a significant amount of current needed for the motor to reach its peak performance. This is where the concept of six-phase motor comes into play. A six-phase motor essentially operates as two three-phase motors working together. This configuration optimizes the distribution of current, reducing the buildup of heat. A six-phase motor has 6 sets of coils, spaced 60 degrees apart, resulting in a smoother magnetic field and improved reliability. It can handle higher currents without overheating, thanks to the increased number of coils. Additionally, its use of smaller wires reduces weight and cost. A six-phase motor is a technological advancement in the automotive industry that offers improved efficiency and power density. It provides higher torque per ampere, reduces interference, and enhances overall performance. Koenigsegg has innovatively integrated 2 of these motors into a single housing, a significant breakthrough for the automotive world. This innovation marks a departure from the conventional three-phase motors commonly found in most electric vehicles. In a three-phase motor, the stator has 3 sets of copper coils that generate the electromagnetics for the motor. The number of coils can vary, with some motors having only 3 coils, while others may have up to 33, depending on the design. In the automotive industry, motors in radial flux configurations typically have around 6 to 9 coils. In contrast, a 6-phase motor combines 2 3-phase motors to function as a single unit. The key advantage of this approach is its ability to handle higher current levels more effectively, improving efficiency and reducing heat buildup. Splitting the current between 2 sets of coils reduces the risk of overheating and enhances motor performance and reliability. A 6-phase motor increases power output without increasing size or weight, benefiting high-performance vehicles like Gamera. Koenigsegg's use of a 6-phase motor aims to enhance Gamera's performance and efficiency for a powerful Grand Tourer. But the improvements don't stop there. By integrating a single dark matter e-motor with the advanced light-speed torque beyond transmission, or LSTT, the Gamera's powertrain undergoes a remarkable transformation. The LSTT, derived from the original light-speed transmission developed for Jesco's TTV8 engine, provides the Gamera with an efficient and seamless power delivery system. Thanks to this engineering endeavor, the Gamera's overall powertrain becomes lighter, more compact, and incredibly agile. Drivers now experience exhilarating acceleration, and the Gamera effortlessly conquers any road it encounters. Dark Matter's e-motor enables efficient electric-only driving in the city, while the TFG, which stands for Tiny Friendly Giant, provides power when needed. Together, they create the Gamera's astonishing 1,400 horsepower and 1,365 pound-feet of torque, maintaining all-wheel drive, 4-wheel steering, and torque vectoring capabilities for exceptional handling. This high-end custom motor uses additive manufacturing and advanced techniques like 6K microwave plasma to create precise nanoscale alloys. As the Drive newsletter says, without cracking one of these motors open, which I don't think has happened, as we can only speculate though, the bottom line is that Koenigsegg has, once again, developed some very interesting automotive technology. We've also seen the emergence of algorithmic engineering, which allows for detailed simulations and potentially more intricate 3D motor designs. In the future, with motor technology innovations, we could eventually have room temperature superconductor motors and may even surpass the Koenigsegg's dark matter motor's capabilities. So are you intrigued by Koenigsegg's groundbreaking dark matter engine? What are your thoughts on this game-changing innovation? Let us know in the comments below. And don't forget to hit that like button and subscribe for more cutting-edge automotive updates. Thanks for watching.